Okay, well, it's 10 o'clock and it's time for another Long coffee break. My name's James Murphy. I'm a senior sales engineer here at Long. Today, we're going to be talking about high efficiency heat recovery. We're lucky enough to be joined by with us by Dean Sherrick, and he's with Tempeff. And I'll pass it over to Dean and we'll get going.
Welcome. Good morning, everybody. What I'd like to do is go through what Tempeff has to offer from an energy recovery standpoint. We are an organization that's based out of Winnipeg. I am on the East Coast in Pennsylvania, but we build custom air houses with energy recovery, mainly around our DUALCORE Plus product, which is what we're going to talk about today. With that stated, we're looking at what do we have to offer and how does it fit into energy recovery. Traditional options, wheels, heat pipes, cross-flow plates are all units that we will manufacture in semi-custom options. They all work. You'll have efficiency rangings anywhere from 35 to 80%. But the one downfall you have to take into consideration in colder climates is a defrost strategy. Each one of those will need a defrost strategy. You're either going to slow a wheel down, reduce your supply temperature, you're going to preheat to 20 degrees to get performance, which costs energy, or you're going to bypass air and then you're going to have to heat all that air up to your neutral discharge. When we talk about dual core, otherwise noted as regenerative technology, as outlined by ASHRAE in 2019, it is a system utilizing two sets of cores, but what it does for us is eliminates the need for a defrost strategy or preheat within the system. So the advantages of the system in heating mode with the way this system works, and we're not talking about a new system, we're talking about a technology that's probably 45 years old, but not heavily recognized in the States. But the fact of what we can provide you is 90% sensible efficiency in the winter, up to 70% latent efficiency in the winter with the dual core product. And then in the summer, we'll provide you 80% sensible efficiency with an option for a product called DUALCORE Plus, where we put in a desiccant coated latent core, which I'll explain later, that'll give you upwards of 60% latent efficiency. So when you're sitting at 90% efficiency, it's probably the highest that's available on the marketplace. But the big benefit is the fact that we do not need defrost. So with the requirement of not needing defrost, when you talk about a cold climate, and we'll say maybe a -20 climate with 70-degree exhaust air, on your coldest day, I'm going to provide you somewhere around 60 degrees with no additional heat. So with that stated, what we talk about is right sizing equipment, which means why put in 70 degrees of delta T into a unit if you only need 10 degrees to get to neutral? Therefore, you can save in gas line sizing, or maybe consider electric heat on the reheat standpoint, or not run a hot water coil or need a large hot water coil. So that is the benefit of the system. So with that stated, it's a pretty simple standpoint of, well, how does it work? What are you talking about? It is simple. It is the utilization of aluminum plates stacked into cores that will hold the energy and discharge the energy. Here's an example of the cores in a section of an air house that you can see in there. Note that there's three levels of height within this, as well as there might be 2 or 3 levels in depth. The max weight for one of these cores is roughly 65 pounds. The other commonality with regards to these cores is every core that we utilize, from 100 CFM to 60,000 CFM, which is roughly our largest, is all 39 inches in length, which means your airflow through that core will see 39 inches of aluminum. You want to clean them, you pull them out, you pressure wash them, you put them back in. With that stated, you're looking at a situation that the benefit of these cores obviously is storage of thermal energy. When you look at the plates and the stacking itself, they are considered fluted, roughly at a 40-45 degree angle, and they're stacked opposites. Therefore, your static on this is usually less than 1/2 inch.
Dean, with you guys calling it a dual core, it's probably a little bit different air path than we're used to seeing in a normal heat recovery. Can you maybe expand on that a bit?
Absolutely. That's not a problem. One other thing I want to mention as well, when I talked about 39 inches, so you understand what we're looking at, the face area of these cores are all sized based on face velocity. With that stated, I need at least 200 feet per minute going across the core with a max of 500 feet per minute. So the more airflow I have, the bigger the cores become, or the more modules that I will put into that system. As you approach 500 feet per minute, your efficiencies will begin to fall, but as you approach 200, they'll begin to increase. So with that, it's like, yes, how exactly do you mean? Where do you come up with dual core? How does it work? Well, it's pretty simple because we can all count. Every air house that we build has 2 cores in it. Therefore, it's called dual core. Let's make an assumption that this is an air house sitting on the roof. So let's draw a box around it. So what do I have? I have a damper section. I have my supply fan, exhaust fan, which by the way, they are direct drive plenum standard. Then I have my 2 cores. My supply fan, which I come out of my damper into my supply air plenum, which is going to go into the space. My exhaust ductwork is going to come in with my exhaust air. It's going to blow air into the damper. So supply pulls from the damper, exhaust blows into the damper. Each one of these, if it's sitting on roof, just assume it has louvers on the outside of the cores. What we're going to do is manipulate these dampers to vary the flow of the air to energize and de-energize the cores. So we always have one being energized and one being de-energized. And how does that look? Wall off the center of the air house, which basically means close the vertical ones, open the horizontals. If I am going to pull supply air, it is going to come through core A into the space. Humor me, act like I have energy in this core, and I come in with -20, I run through it, and I come out with 59 degrees going into the space. While that is occurring, my 70-degree exhaust air is being forced out core B. What am I doing? I'm loading up all those aluminum plates with energy. I will stay in this mode for 60 seconds. After 60 seconds, I open the verticals and close the horizontals. What does that do? I can no longer pull air in across core A because I've walled off the center of that damper. Where's my air going to come? It's actually going to come back in core B. So I was exhausting air out. Now I'm going to bring it back in core B. So I take my -20, my 58, 59 degrees into the space. My 70-degree air is going to go out core A, which I just de-energized in the previous cycle. So now I'm going to reload it. So what you look at when you put them side by side is I have these 2 modes that will operate and switch over every 60 seconds. Unload one core while you're recharging the other. Therefore, why do I not need defrost? I don't need defrost because a core gets to see warm exhaust air every 60 seconds. And that's what allows us to eliminate. The 39 inches and the 60 seconds are 40 years of testing to maximize our efficiency. Of course, you could go shorter aluminum and quicker turns, but it's something obviously that there's a couple things we're looking at. We want to maximize efficiency, but we also want to minimize what we call cross leakage. I will point out these are not 0 cross leakage units. They are 1 to 3% cross leakage in the winter, depending on face velocity on the core. And with that stated, we still meet class 2, which is 10%, which is bathrooms and locker rooms. We actually will meet class 3, which is 5%. The difference is obviously class 3 might be a lab, and that's going to be your decision, engineers, if you'll accept the cross leakage or not. So this is the operation of the unit with how it works. This is what we considered our standard dual core, which is a sensible unit only. You all know you're all concerned about, hey, you're turning dampers every 60 seconds. You've got moving parts. How's that going to affect us? All of our dampers are driven by electric motors. In our units, as you can see, this is an electric motor with a gearbox. With that stated, the motor spins in the same direction every time. They're energized for about 2 seconds. With that, you can see the damper assembly within that we build itself. There's going to be a motor for vertical dampers and motor for horizontal dampers. I can tell you we only have 2 SKUs in everything we build, from 100 CFM to 60,000 CFM of motors, a small and a large. With that stated, those motors are then hooked to linkages. These are hard linkages set up at the plant. To give you an idea, the dot right here is the drive shaft coming out of the gearbox that the motor's driving. Has an oblong plate on the unit with a hard bar to another plate. Here we have the top vertical damper, a hard bar down to the bottom, and a lever for the bottom vertical damper. When we energize the motor for that 1.5 seconds, it'll spin this plate upwards to a trigger point, which will stop. Obviously, this plate will go up, the lever will come with it, and I just change the dampers. Then when we energize again, we rotate in the same direction. We're not going back and forth like an actuator. Rotate it down and push them down. So these will go up and down. These will go left and right as you open and close those dampers. On this linkage system, we have a controller for the timing. We have manual auto switches. We have supply and exhaust air temperature sensors. So you can set up when you want free cooling. Free cooling for us is do not change the dampers. You don't change the dampers when I no longer have energy in the core. All I have is outside air. So to give you an idea how the unit operates and what it looks like, unit that runs at the plant 24/7. It's going to go about every 2.5 seconds because we're doing a life cycle on it. We want to see how long the unit will run. This system has over 50 years of operation on it if I was running an energy recovery with every 60 seconds turn. I can tell you in the history of the company, which we're not a young company, we've been around for 13 years. We've had a handful of motor failures in 13 years of building product. It's very reliable. Nothing here needs to be taken a look at or changed with. You then have the dampers. Fans do not stop running. Supply and exhaust run. The dampers are top and bottom compression seals. They're dual plated. There's bridges on them because we want to make them as light as possible on the unit, and we want them to obviously seal. I think at 3 or 4 inches of static, when these dampers are closed, we have less than 1% of leakage on those. So that's what those dampers and that system looks like.
Dean, when you're charging and discharging the core, does your supply air temperature vary between the end of the charge and the start of the charge kind of thing?
That's an excellent question. And the answer to that is our temperature will vary on our supply air by less than 1 degree while that unit runs. So if it's -20 outside, we designed it that it was going to give you 59 degrees and it ran for a month at that, it would be 59 degrees plus or minus a degree. And the science behind that is you never completely de-energize a core. Basically, with that stated, you will always have energy in there. You're not taking it down to what the outside air temperature is. So that is a huge benefit when you're looking at maybe supplying the back end of some other equipment that requires certain temperature air. It'll also allow you to help track better when you say reheat that air back up coming into the space. Recently, in the past year, applied for a patent in the US and Canada. The Canada patent has been passed. We're waiting for the US patent to pass. What we've included in this, in markets that require it, is the fact that if you're in a market that might be running cold, that you need no defrost, but you also are designing around 95, 75, we've now included a desiccant section core in the system. And basically what we've done is we've cut out 12 inches of aluminum. So we went from 39 inches to 37 inches, and we put in 12 inches of an aluminum desiccant 3 angstrom coated core. And that will allow us to help you save that 20 to 30% in your cooling load that you might currently utilize or see in an enthalpy core or say an enthalpy wheel. What it does do is it does add filtration to the unit. Because the latent core, which will say it actually looks like an aluminum wheel, is a much smaller opening. I've got to put filtration in to protect it when that outside air comes into that latent core. The same way goes with the exhaust air. I will put filtration in the exhaust air to protect the other side of the core that's next to the damper. So with that, there are some extra filters to it, but now what you end up with is you end up with a super efficient unit when you're talking about 90% sensible in the winter, 70% latent in the winter, 80% sensible in the summer, and upwards of 60% latent in the winter. It's the best of everything that you're looking at when it comes with the system itself. So this is an option for those applications and those markets that are looking for it. To give you an idea of performance, here's a system, and when we talk numbers and efficiency, it's usually based on a 1-to-1 airflow. But in this case, it was a job that was 8,000 CFM of supply, 7,800 of exhaust. It was a -20 climate, 70 degrees, 50 leaving the space. And in this case, I was providing 59.02 degrees on a -20 day.
Dean, where was that job located?
This is an actual project that you all have sold that's on the production floor right now for Gunnison Airport.
And can you briefly talk about efficiency versus effectiveness?
Yeah, everything that you see me talk about when I look at these units is we talk in efficiency. So in this case, this unit is 87.8% efficient. Efficiency and effectiveness are the exact same number when your supply and exhaust air are the same. It was decided that because your efficiency number will fall when your exhaust air falls, so let's just say this was 7,000 CFM. Now this is going to be 87.8%. This isn't going to be 59 degrees because I have less energy leaving. So this number might fall to 50 or 83%, and this falls to 56. What they've done with effectiveness is they said, okay, take your efficiency number, take your supply divided by your exhaust, which is going to be 1 point something, and multiply it by your efficiency percentage. So all we've done is we've graded this on a scale. So that 88% now becomes 93%. Does my 59 degrees change? Does my BTUs change? Absolutely not. All I did was increase the percentage to make the number look good. So that's the difference between efficiency and effectiveness. Of course, you can't do a negative effect of that, as in if you have more exhaust air than supply air, that would hurt your percentage. It's capped at 1-to-1. And most applications, we don't want to see less than 80% exhaust to supply because the energy at that point is too low. So overall, what's the system offer you? It offers you an option to what you're currently doing. We have a lot of opportunities where there might have been a restriction or a total amount of natural gas that might be coming onto the space. Well, if I don't need 70 degrees of delta T, I only need 10, that's less gas usage, which obviously is less installation cost. As electricity becomes more popular, it allows for a small amount of electricity to be used on the backside to reheat that air. And also note, when I say 59 degrees at -20, that's on your coldest day. If it's 20 degrees outside, I might give you close to 64 degrees. Therefore, you're approaching neutral with very little heat. I have no defrost strategy, so I don't need preheat. It's low maintenance, which means the cores can be pressure washed. The desiccant cores obviously have to be cleaned with a vacuum or compressed air. You have filter replacement on that system itself. You have self-purging cells. We have designs up to 60,000 CFM. I've got different configurations from same end connections, indoor units, outdoor units. Long-term performance. You don't remove the cores, you don't change your temperatures, you don't change the CFMs. This unit should work the same as it does day one as it does year 15. They actually proved it on a unit in Sweden. So it's been around a while. It's something new to take a look at, and it's something to consider as your customers might want super high efficiency, or they might want to reduce the amount of additional heat that they're using. With that said, that's what we have. Also note, I am going to be making a trip to Denver in September. So if for some reason that you wanted to see more with what we had to do, obviously talk to your favorite long sales engineer. But I appreciate the time.
Thanks everyone for joining us. Please join us next week. We have a special edition of the coffee break. Bill, Roan, and myself will be doing it. So thanks again, everyone. Have a great day.